Hey everyone, time is suspect. At least that's how Einstein famously put it. We will be exploring today the relativity of simultaneity, keeping in mind the two postulates of special relativity, the principle of relative motion, and the principle of light constancy. Remember that second one was where the speed of light is the speed at which light travels, always, no matter what. Light always goes the speed of light. Now I've got our friends Alice and Bob. In this first diagram, we see that they're both stationary. They each have a clock on either end of their spaceship, back and the front, and we're shooting a light pulse towards each of these clocks, starting from the center of the ship, or the middle of the ship. And because both of these observers are stationary relative to each other, that means that the light pulses are going to hit both of those clocks simultaneously at the same time. Both clocks get hit at the same time and in both observers' points of view. You have these little cameras that record the times that are on the clocks, etc. Now let's talk about paintballs. So here we're talking not about light and not at relativistic speeds. If we shoot off paintballs in Alice's ship, if she is moving relative to Bob, and Bob has this lattice of clocks and they're all starting off at 0, we shoot off these paintballs at both clocks. As Alice is moving, Bob is going to observe U minus V for the left paintball and U plus V for the right paintball. And that's just simple Galilean addition of velocities, as we've seen before. And Alice, of course, will just observe them both going at velocity U. Now, as those paintballs move along, they will both hit simultaneously according to both Bob and Alice. And because these are paintballs and they're not going relativistically, they're just going to hit both ends of that spaceship at the same time. Bob and Alice recording the 2 times respectively. Now, what if we go back to light? Here, we shoot light pulses off in Alice's ship, but Alice is moving with a velocity v. Now, the speed of light is the speed of light for both Alice and for Bob. So Alice will observe them similar to the paintball scenario, both going off in the same direction or in the different directions at the same velocity. Bob will also see those light pulses move off both at C, but Alice is moving towards the leftmost light pulse. So what that means is that this light pulse is going to end up hitting first according to Bob. And we'll see that right here. In 3.2b, the light pulse hits the rear clock at TA, or TB1, and records that time, sees that happen. But as you can see, the right pulse has not yet hit the front of the ship. The second light pulse will then hit the front of the ship. It'll also be recorded as TA according to Alice, right? Because both of those have to be simultaneous in Alice's frame. But Bob will observe this as occurring at some later time, TB2, and Bob will say that the rear clock is at some time greater than TA. Bob says his clocks are all synchronized, And Alice's clocks are messed up. Alice, you got to work on your synchronization of your clocks. They just aren't making sense. And Alice is the converse. So what are the conclusions that are drawn? Well, Alice just says, hey, they both hit at TA. Nothing's going on. I'm stationary. Everything's moving at the speed of light away from the middle of my ship, hitting both of my clocks at the same time. But Bob's conclusion, as we had said, the rear clock gets hit first, and the leading clock, or the front clock, hits second. And this is the concept known as leading clock's lag, that a forward clock will lag behind the clock in the rear of a ship, in this instance. And again, even though we have some type of photographic evidence on both of these clocks, Bob will just say that the clocks are not synchronized for Alice, whereas Bob's clocks are all synchronized. And therefore, although Alice says things are simultaneous, Bob says they're not. And they're both right. And so we can see that even though we've got both light pulses hitting according to Alice, and Bob will agree that he sees Alice's clocks reading as TA when they both get hit. But again, he disagrees about the notion of simultaneity for Alice's clocks. Alice's clocks are not simultaneous in his frame, and vice versa. All right, so Bob claims that Alice's clocks are messed up, and Alice claims that Bob's clocks are messed up. And they're both right. So how do we make sense of all this? Well, as Einstein had put it, time is suspect, or simultaneity is relative, because we have this leading clock's lag notion when something's in motion relative to a stationary observer. Simultaneous for one observer is not simultaneous for a different observer in a different inertial reference frame. Clock synchronization is relative, and absolute time does not exist absolutely. All right, well, that's all I wanted to cover in this video. Remember, simultaneity is relative and leading clocks lag. Take care.